So as we've mentioned, light is an electromagnetic wave that comes in different colors. That's how we perceive wavelengths of light. So here I've got an incandescent bulb, and we perceive this sort of bright white light. But what's actually happening here is electrons are going through a wire, they're heating it up, and that wire is radiating a thermal spectrum of radiation that includes all wavelengths of light. So we're now going to put a diffraction grating in front of the lens of the camera, and you should see on either side here a rainbow of all the different colors. And what's happening is that all the colors coming from this light are passing through that diffraction grating, and depending on the wavelength of light, they're bending by different amounts before they reach the camera lens, so that they appear to be coming from over here or over here instead of from the light bulb. But what this illustrates is that this light is actually made up of many different wavelengths of light. And I can filter some of those wavelengths out. So here I've got a translucent piece of blue plastic, and if I put that in front of the light, then this is passing more of the blue light and less of the red light that you'll see in that rainbow of colors. Or if I take a translucent piece of red plastic and put it in front of the light, then you're seeing more red light pass through and less of the blue light. So that's an example of absorption. It can maybe be seen more clearly if we take a look at a light that only emits certain wavelengths. So let's lower the diffraction grating, and this is now instead of a wire, it's a tube that's filled with hydrogen gas, and we're passing electricity through that gas, and that causes it to glow, and it has a sort of a purple color. And if we take a look at the individual wavelengths making that up, let me put it over sort of more in the middle here, then you'll see again on either side a couple of narrow lines that are sort of bluish and reddish and purplish lines that instead of a nice continuous rainbow, we just have a few like copies of images of this light bulb, this narrow thin light bulb on either side. It's the same thing on either side, and those are the handful of different wavelengths that are emitted by this. And that has to do with the particular structure of the hydrogen atoms that are in that tube, their atomic structure. And again, then we can filter it. We can put a blue filter in front or a red filter in front, and it blocks different amounts of the different colors that are showing up there. And that might be easier to see with a neon light. And neon fluorescent bulbs we're familiar with at restaurants. So this tube is filled with neon gas. It's glowing with a different color, and if we look at the different wavelengths that are making it up, we see that there are a whole bunch of lines on either side that are mostly in the sort of reds and yellows that when combined give the neon its characteristic orange color. So if I put a red filter in front of that bulb, most of that light's still going to get through because most of the wavelengths are still in the red. But if I put a blue filter in front of it that would normally allow the same amount of total light to get through, it's blocking more of that reddish and orangish light from getting through. So this is analogous to what goes on with the atmosphere, which is like a piece of plastic over the surface of the Earth. The surface of the Earth is radiating infrared radiation, which we can't see with our eyes, and the different gases in the atmosphere absorb some wavelengths of light, just like neon and hydrogen emit only certain colors. Carbon dioxide, water vapor, methane are molecules that absorb certain wavelengths of light in the infrared. They're transparent to the visible light that comes in from the sun, but when the Earth radiates those longer wavelengths of light, we've got absorption filters over the Earth in the form of those gases in the atmosphere that prevent that light from getting out into space.